Hello everyone. What we'd like to start doing in section 6.5 and section 6.6 is start working with non-right triangles. This entire quarter, everything we've been doing has been with a right triangle. SOHCAHTOA, when we started thinking about the 6 trig functions, they were defined as ratios of the sides on a right triangle. What's another great tool we had? Pythagorean theorem. Pythagorean theorem only works on right triangles. And when we thought about the inverse trig functions, well, those had to do with right triangles. So how do we work with non-right triangles? And that's what we want to start doing. What are the rules? What are the tools we have at our disposal that if we know some information about a triangle, not necessarily a right one, how could I figure out the other sides and the other angles? That's what we want to start doing. What we're specifically going to do in this video is we're going to just define some of the language that goes with non-right triangles and also start thinking about how much information do we need to know about a non-right triangle to be able to find the other information. So we want to think about what is the minimum amount of information we need to know about a triangle to be able to find all the other information about it. Okay, so here's some vocab. So when we are talking about non-right triangles, so here's a non-right triangle. We often use capital letters to talk about the angles. Now, I could label these however I'd like. So how about with capital letters? This means angle A, so this is the angle here. Capital letter B, that'll be this angle. And capital letter C, that'll be this angle. So capital letters will stand for angles. Now, you might see the book, and maybe sometimes I'll use it. Sometimes I might forget. But they'll put kind of this symbol right here, this kind of 2 lines. This means angle. You might see angle A, or angle B, or angle C. I may sometimes forget to kind of put this angle symbol right here, and sometimes I might just use capital letters, but they mean the same thing. So capital letters mean angles. We use lowercase letters for side lengths. And we always think about the side that's opposite to an angle. So if this is angle A, what I would call its opposite side, I would call this side A. If this is B, the A side that's opposite to it, I'll write as B. If this is angle C, the side opposite to angle C is what we'll call side length. Side length C. So capital letters are angles, lowercase letters are sides. Now, don't get confused with labeling. Just because I put A, B, and C here, it doesn't really matter. I could have said this is B. I could have said that this is A, and then that this is C. But now this is just going to change the labeling. Now I would call this side length C. I would call this side length A, and I would call this side length B. So the labeling doesn't really matter. So all we have to know is that if you have an angle, capital letter A, what I'm calling the side A, the lowercase little a, is the side that's opposite to the angle. Okay, so now here's just some information. It turns out that we need to know 3 of the triangle's 6 parts. There are 6 parts. There's 3 angles and 3 sides. We need to know 3 of them to know about a triangle, to know all the information about it. So I'm going to kind of write this. So to solve a triangle, we need to know 3 of its parts. With one of them being a side. Being a side. I'll talk about this here in a second. So I need to know 3 things about a triangle, and one of them has to be a side. And I'll talk about the language we use for these different types of triangles. But that's what we need. We need 3 pieces of information, and one of those pieces of information has to be a side. Okay, so let's talk about those types of triangles, or what we kind of give their names. We give them special names. Okay. So we have a couple different cases. Okay, the first case, which I'll call case 1, is we could know 2 angles. And this is really the best case. So we know 2 angles and a side. We know 2 angles and a side. Okay, so let's draw the situations. Okay, so here we have our triangle. Okay, so let's say that we know this angle A, we know this angle B. Okay, we would know these, and then we know one of the sides. So for right now, I'm going to draw a dash here. It means we wouldn't necessarily know this length. We wouldn't necessarily know this length, but we would know, let's say, this length here, which I'll call lowercase c. So if we know these two angles and the side in between them, this will uniquely define the triangle. So we have two angles. Now this could be a lot of different triangles, but as long as I know this length in between them, this will lock the triangle in place. Now specifically, I'm saying that I know the side length between A and B, so we write this type of triangle, or we're knowing this type of information in a special way. What we know is we know angle, side, angle. So we denote this as an angle, side, angle, triangle. We know two of the angles, and we know the side in between them, or this will be an ASA triangle. Okay, similarly though, we could know an angle. Say we know angle A and we know angle B, okay? But maybe we don't necessarily know the side in between them. Maybe we know this side here instead. We know this side here instead. Okay? Well, you could adjust what this B is to make sure, so if this side length here is fixed B, you could adjust this side length to make it work as a triangle, to make everything fit. So if we know this side and these angles, we could figure out what this angle and these two sides would need to be for this triangle to be locked into place. So we call this one a side angle triangle. So this will be a side angle. This means I know two of the angles of the triangle, and I know a side, but the side is not in between the two angles. Okay. So side angle. Okay, this would be the same. This would be the same even if I said this is A. This would still be a side angle. I know two of the angles, but I don't know the side in between the angles. So this is case 1. Okay, there is case 2. Case 2, maybe I'll erase a little bit of this. There's case 2. Case 2, okay, what if we know two sides? We could know two sides and an angle. Okay, and an angle. And let's say an angle not between the sides. And an angle not between the sides. Okay, so what this would mean is we would know one angle. Okay, so let's say we know angle A. Okay, so let's say this is side length B, and this is side length C. Or sorry, this would be side length A. Okay, so we would know these two sides and this angle here. So what would we call this type of triangle? Let's see. So this would be an angle, a side, and a side. No. I mean side angle. Oh my gosh, my daughter's out there. This is a side. This is a side angle triangle. Side angle. So this means I know two of the sides, but I don't necessarily know the angle in between them. This is what we'll call case 2. Okay. I will talk a little bit more about this specific triangle, the side angle triangle, not the ASS triangle. This is sometimes called the ambiguous case. The ambiguous case. We'll talk a little bit more about this one in the future. But this would be a side angle triangle. Now, when we're ever in a situation where in case 1 and case 2, this is where we'll use a tool that's called the law of sines, and we'll talk more about that later. Okay, we have 2 other cases. We have case 3 and case 4. I'm sorry if this is kind of just listing these cases. Sorry, just a little bit boring. This will be a lot better once we start doing examples. But let's just get through kind of these situations. So case 3 is we could know two sides. We know two sides and an angle between them. Okay, so that means we would know two sides. Maybe we know two sides. So let's say this is angle A. Say this is length B, and let's call this length C. So if we know two side lengths in the angle in between them, then we could define this triangle. So we would call this a side angle side triangle. I know two sides and I know the angle in between them. Okay, the last case, case 4, is, well, we could know all three of the sides. So this is A. Let's call this one C. This is called this one B. So if we know all three sides of the triangle, then we could be able to figure out the angles. This would uniquely define this triangle. We call this a side, side, side triangle. Okay. If we're ever in case 3 or case 4, we're going to use a tool that's called the law of cosines. Okay. So these are the 4 different cases. Case 1 and case 2, we'll be using a tool called the law of sines. Case 3, case 4, we'll be using what's called the law of cosines. Now, do I have it memorized that I know when I have this specific triangle that I use this specific tool? No, I do not. What I do is I just think about what pieces do I have, how do these tools work, and which one's going to help me out here. So I'm really bad at memorizing things. I just like to draw the picture and try to think about what I have at my disposal. Okay, so notice here that I do have to know at least one of the sides. So the last thing I want to talk about is you couldn't just know the angles of a triangle. This wouldn't work. Angle, and an angle. Okay, this wouldn't work very well. Okay, because if this is angle A, this is angle B, and this is angle C, okay, well there are multiple triangles that would work here. Okay, so if I just kind of extend this out and thinking about making this length here, I'm trying to keep this, the slopes of these the same. Notice here that I have two triangles and I preserved the angles. So this would still be angle C, this would still be angle B. So if you have a triangle and you know the angles, you could just scale it. The angles will stay the same, but the side lengths will change. So it's not enough for us just to know the 3 angles because there are an infinite number of triangles that would have any. If you give me 3 angles for a triangle, there are an infinite number of triangles that'll have those angles. You could just scale it. Okay, so the key thing that we learned in this video before we start working with our tools is we should have learned the vocabulary for non-right triangles. Capital letters are angles, lowercase letters are sides. We have some vocabulary for talking about the different types of triangles that we have. So we have to know 3 pieces of a right triangle. We have to know 3 pieces of a non-right triangle to know everything else about it, and one of those pieces has to be a side. And we have case 1 and case 2, we'll use the law of sines. Case 3, case 4, we'll use the law of cosines. But again, I don't have those memorized. So let's stop talking about all this stuff. Let's just start doing some examples. We'll do that in the next video. We'll see you there. Take care.